So, now let us look at the specific things of specific issue of framing. Translates the physical layers raw bit stream into discrete units called frames. So, sender is sending and the receiver is receiving. Sender has sent frame 1, frame 2 to frame n. So, you see n frames are on transit and it is going from the sender to the receiver. Now, how can the receiver detect the frame boundaries? Okay. That is, how can the receiver recognize the start and end of a frame? There are 4 methods: length count, bit stuffing, character or byte stuffing, or pulse encoding. So, we will look at some of these now. Now, frames could be fixed length like ATM, alright. So, ATM cells are of fixed length. So, you know once you have synchronized, you know that they are going to come with in a 53 byte kind of regularity. But frames could be variable length also, in which case we use this byte count, byte stuffing, bit stuffing, generic framing procedure, Manchester encoding, etc. One is the framing the length count. Make the first field. So, this is the make the first field in the frame's header be the length of the frame. That way the receiver knows how big the current frame is and can determine when the this frame ends. So, if you have a frame 1 is 5 characters. So, if you write 5 over here, so 1, 2, 3, 4, 5 characters. So, you know that this is where the first frame has ended, and the next one say the 6th byte is to be interpreted as the length of the next frame, which is again 5, and then this one is a frame of length 8 and so on. So, you know where each frame ends and the next frame starts. But this has a disadvantage. So, which is that receiver loses synchronization when bits become garbled. If the bits in the count become corrupted during transmission, the receiver will think that the frame contains fewer or more bits than it actually does. Okay. Now, this is a problem in the sense that when you are sending them, suppose due to some error etc., the count field itself has become garbled. Now, the receiver does not know how many bits are there. So, it may make some assumption which may be a wrong assumption. So, now it will interpret some other byte which is a part of something else, maybe data, maybe some other control field or whatever, as the length of the next frame etc. So, once it loses sync, so everything starts getting garbled. So, this is a disadvantage, and this is one reason why this is not used much. You can use a checksum. So, you can use a checksum. So, we will later on see what a checksum is. We will detect the incorrect frames. The receiver will have difficulty resynchronizing to the start of a new frame. So, this technique is not used anymore since better techniques are available. So, one of the better techniques is known as bit stuffing. Okay. Suppose, so use reserved bit patterns to indicate the start and end of a frame. For instance, use the 4-bit sequence of 0, 1, 1, 1 to delimit consecutive frames. A frame consists of everything between 2 delimiters. So, you have this 1 delimiter on one side, 0, 1, 1, and then the frame, and then the other 0, 1, 1. So, this as soon as you get a 0, 1, 1, you know that a frame is starting, and as soon as you get another 0, 1, 1, you know that a frame has ended. So, this way we can know the beginning of the end of a frame. Okay. Well, obviously, I do not know whether that is obvious, but there is a problem with this. Problem is, what happens if the reserved delimiter happens to appear in the frame itself? If you do not remove it from the data, the receiver will think that the incoming frame is actually 2 smaller frames. So, you understand the problem is very simple. Suppose this we have the 0, 1, 1, 1 as the delimiter, but the data itself may contain that means data which has come maybe from the user. Okay. This may contain any bit pattern, and actually you have to allow any and every bit pattern to the user. You cannot say that you cannot send the 0, 1, 1, 1, 1 because it may be some maybe picture is being sent through a number of frames, and the bit patterns may be absolutely arbitrary. So, in that case 0 or 1, 1, 1 may very well appear in the body of the data. So, this is where that bit stuffing part comes. What we do is that we introduce another kind of pattern, let us say the same 0 for each 0 which appears inside, which means that for the preamble and the preamble on the beginning and the end, we use this 0 and this 0 this unit appears singly at these two places. In the body of the frame, if 0 needs to appear, instead of 1 0 we put in 2 0 So, if the receiving end sees 2 0 one after the other, it knows that the it actually is bit stuffing, and it will reduce it to only 1 0 in the body, alright, whereas the preamble and the postamble will appear separately. So, the solution is to use bit stuffing. Within the frame, after every occurrence of 2 consecutive ones, insert a 0. This is another example of a bit stuffing. Okay. So, after every if there is a consecutive 2 consecutive ones, insert a 0. For example, append a 0 bit after each pair of ones in the data. This prevents the 3 consecutive ones from ever appearing in the frame. So, some bits have been introduced after every 2 ones in the data, we insert a 0, and the receiver knows that if I encounter 2 ones and then there is a 0, this 0 is actually a bit stuffing. So, this 0 will be dropped from the actual data. So, this way these 3 ones will never appear in the body of the frame, whereas it will appear in the preamble and the postamble. Similar to bit stuffing, we may have byte stuffing. For example, let us say a flag, say some character is there, like say flag, which is also a part of the, which may be a part of a regular header, but this just happened to appear in the body of the frame or body of the packet. So, what we do is that we use this other character. So, that is why these are character introduction. So, that is why it is called byte stuffing. 1 byte is 1 character. So, we introduce the character escape character just before the flag. And what happens if escape itself appears in the body? Well, we put escape escape. So, if there are 2 escapes side by side, we know that we have to interpret it as only 1 escape. If there were 2 escapes in the original data packet just by chance, then actually this will be what will be sent are 4 escapes, and just one after the other, and the receiving side for each 2 escape, it will reduce it to 1 escape and know that this is just a part of the data. Only at the end that will we will get this flag etc. by itself. Okay. If there is escape flag, we have escape 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 flag, escape escape and so on. Okay. So, this is known as byte stuffing.